Ever since COVID-19 pandemic, the new normal has occurred in almost every country in the world. The World Health Organization, or WHO, has recommended us to frequently wash our hands with soap and water for a minimum of 20 seconds, but if that is not possible, the second best choice is to disinfect with alcohol-based products. The good quality alcohol product should have two main qualities. Firstly, the alcohol concentration should be over 70%, but preferably not over 90 to 95%. It should not compose of toxic substances such as methanol. Therefore, it has become our goal to determine the type and amount of alcohol in disinfectants with a simple assay.
To create a visual detector for alcohol content, anthraquinone is one potential substance. This substance, besides currently being studied for medical and pharmaceutical benefits, it actually has been used for as long as a natural dye derivative of anthraquinone, despite their structure similarities often be seen in different color to the naked eye, especially if dissolved in different organic solvent and acidity. In order to acquire anthraquinone, morinda kitiphyllin is usually one of the resources. We use its dry stems cut into powder, then solid attractor to attract anthraquinone for 24 hours. Then solution mixed between hexane and dichloromethane is used for column chromatography to get anthraquinone derivative, followed by 3-layer chromatography for purification. Finally, the substance is left for evaporation. The anthraquinone will be left as sediment. And these are the spectrum of anthraquinone A we can extract. Because we aim to find the anthraquinone-based reagent formula that can differentiate alcohol qualities, we have to first set some variations of the alcohol samples to be tested. We vary alcohol among 3 independent factors including percent alcohol content 50, 70, and 90%, alcohol type ethanol, isopropanol, methanol, finally pH level acid, neutral, alkaline. Next, we add the reagent to those testing conditions. The final observation of color or any physical changes will be recorded as dependent variables. Note that to create all testing conditions, we start with 95% alcohol that dilute with distilled water to get the 50%, 70%, and 90% levels. On the other hand, start with hydrochloric at pH 1 gradually dilute with water. We can create hydrochloric with pH level 5. Performing similar steps with sodium hydroxide, we eventually get sodium hydroxide at pH level 9. The dilute hydrochloric and sodium hydroxide are used to adjust acidity level of the to-be test alcohols. Now, all the testing conditions are ready to be tested and observed.
The alcohol conditions were later tested with 3 types of reagents. Each type was graded using the extracted anthraquinone, confirmed to be damnacantho. We dissolved it with 3 solvents, including dichloromethane, dioxin, and acetone nitrile. By adding the reagent to alcohol conditions, here are the results. First, the chloromethane reagent show a drastic color change into dark orange under alkaline conditions. We don't want a reagent that has high sensitivity to alkalinity levels. Therefore, dichloromethane was excluded. Then, acetone nitrile reagent cannot clearly differentiate between ethanol and methanol, as both result in a very similar light yellow color. Dioxin gives the best differentiation results. After filtration, we found that the methanol results in orangish color compared to light yellow found in ethanol and isopropanol. Then, the yellowish color is found to be a gradient according to alcohol concentration. The darker yellow equates to higher alcohol concentration. In conclusion, we have developed a reagent formula to test alcohol type concentration utilizing anthraquinone derivative extracted from Morinda citrifolia lin stem by using dioxin as a solvent. However, our findings still limited by test range to the experimented alcohols. In the following studies, we recommend expanding the range, such as testing below 40% alcohol content and testing with more frequent in between to clearly see the color gradient. Thank you very much.